Welcome back to Logical Thinking, and today we're going to talk about the last two types of valid deductive arguments, the disjunctive syllogism and the constructive dilemma. Don't be scared away by these long, fancy words. I'll walk you through what they mean and how they're helpful for doing proofs and constructing arguments. So the first one we're going to talk about is the disjunctive syllogism, and it goes like this. Premise 1, A or B, so this is the disjunction here, hence the name disjunctive syllogism. Premise 2 tells us not A, and as a result our conclusion is therefore B. So here's an example. Let A be the proposition that tomorrow I go to Cedar Point, and B be the proposition that tomorrow I go to Kings Island. Premise 1 is like saying, tomorrow I'll go to Cedar Point or Kings Island, and once again, or both. Don't get confused by the word or as it's typically used in English. This is a logical or, so this also includes the case of both. Premise 2 tells us not A, so this is like saying, I won't go to Cedar Point tomorrow, and as a result, we can conclude, therefore, I'll go to Kings Island tomorrow. And the question we're going to ask is, does our conclusion follow from premise 1 and premise 2, or the conjunction of premise 1 and premise 2? So let's find out. So we're going to make a truth table here. We're going to put A, B, and I'm going to add a column for not A just to make things a little bit easier. And we're going to have A or B, that disjunction there. So let's make sure we have all possibilities for A and B. We have 4 cases, 2 for A and 2 for each value of B, for each value of A. And let's go ahead and look at this column and just fill out not A really quickly. When A is true, not A is false. And when A is false, not A is true. So we'll go ahead and fill that out. And now filling out that disjunction, we're going to look at A and B together. Remember, A or B is true if either one of them is true. So whenever we see a green line in any one of those rows, we're going to go ahead and put a true. And it's false when both A and B are false. So we're going to put a false there. And now we can ask, does our conclusion follow from the conjunction of P1 and P2? Meaning, does P1 and P2 taken together give us our conclusion? And remember, for P1 and P2 to be true, individually, you can't have the disjunction of the negation of each of them. So P1 and P2 both must be true. So if either one of them is false, we can cross out that entire row to see what happens when we take P1 and P2 together, which is what we're going to do. We're going to first look at premise 1, A or B. Notice how it's false here in this last row, so it can't be false. Otherwise, P1 and P2 would be false. So we can go ahead and X out. This is just because of De Morgan's law. And now let's go ahead and look at that second premise. This tells us that not A must be true, meaning A must be false. So whenever not A is false, we can cross out those rows because once again, this would mean the conjunction of P1 and P2 would be false. So we're going to go ahead and X out rows 1 and 2. And sure enough, we only have one row left, and looking at the value of B, we see that B is true. And as a result, we can ask, does our conclusion follow from P1 and P2? Yes, it does. P1 and P2 in this case imply B. So A or B conjunction with not A implies B. As a result, this is a valid form of argument. We're going to say this is approved, and we can go ahead and move on. The last type of argument we're going to talk about is the constructive dilemma. And it actually has 3 premises instead of 2. And it goes like this. Premise 1, A implies C. Premise 2, B implies D. Notice there are 4 terms now, and A, C, B, and D, A, B, C, and D are not linked at all yet. Premise 3 tells us A or B. This is the disjunction of A and B. And lastly, our conclusion is C or D, the disjunction between C or D. So let me give you an example. Let A be the proposition that tomorrow I go to Cedar Point. B be the proposition that tomorrow I go to Kings Island. C be the proposition that tomorrow I ride Steel Vengeance. This is a ride at Cedar Point. And D be the proposition that tomorrow I ride the Beast. This is a ride at Kings Island. Premise 1 is like saying, look, if I go to Cedar Point, I will ride Steel Vengeance. Premise 2 is like saying, if I go to Kings Island, I will ride the Beast. Premise 3 is like saying, look, I'm going to go to Cedar Point or Kings Island, and our conclusion is, therefore, I will ride Steel Vengeance or the Beast. And the question we're going to ask is, does our conclusion follow from premise 1 and premise 2 and premise 3? Or does the conjunction of premise 1 and premise 2 and premise 3 imply C, imply that our conclusion is true? So one of the ways we can do this is to construct a truth table. We're going to have 4 variables, A, B, C, and D. So we're actually going to need 16 rows, 2 times 2 times 2 times 2. And let's go ahead and look at all of our premises. We're going to have A implies C, B implies D, A or B, and C or D. So let's start with A implies C. We're going to look only at columns A and C. So I'm going to just blank out these other ones a little bit. And once again, we know A implies C is true whenever the antecedent, meaning A, is false. So we're just going to go ahead and fill that in as true. And A implies C is true when both the antecedent and the consequent are true, meaning both A and C are true. So when these guys are true, we're going to put a T in those rows. And lastly, when our antecedent is true but our consequent is false, A implies C is false. So we're going to go ahead and put a false in those rows. Now let's go ahead and look at B implies D. So I'm going to go ahead and blank out these other columns that we don't need. And we're just looking at B and D. So once again, when our antecedent B is false, B implies D is true. So we'll go ahead and fill that out. When B and D are both true, we're going to put a true. And lastly, when our antecedent is true, but our consequent D is false, we're going to put a false. Pretty straightforward. And now let's look at A or B, the disjunction of A and B. We can go ahead and just look at A and B and blank out these other ones that we just filled out. And remember, A or B is true if either one or both are true, and it's false everywhere else. So it's false only when both are false, so we can put a false in these last 4 rows, and everything else, there's at least one of them true, so we're going to put a true in the disjunction of A and B. And lastly, let's go ahead and look at C or D, the disjunction of C and D. We're going to be looking at just columns 3 and 4, so we can go ahead and hide everything else. And once again, when both of them are false, our result is going to be false. And everywhere else, when at least one of them is true, we're going to put true. So we're going to add that in our truth table. And now what we can do is we can actually look at our premises taken together. So let's look at premise 1, premise 2, and premise 3, the conjunction of all of them, by crossing out where each of them is false. So premise 1, it's false in rows 3 and 4, and 7 and 8. So we're going to go ahead and X those rows out. Looking at our second premise, this is false in these locations. Once again, this is pretty mechanical. You just look where it's false and cross them out. Premise 3 is false in these last 4 rows of the truth table, so we can cross those out. And now let's look at our remaining rows. There are 5 of them. And sure enough, in each of these rows, the conjunction of C and D is true, so we can conclude that yes, C or D does follow from the conjunction of our premises, and thus the constructive dilemma is an approved valid form of argumentation. Thanks for watching, and with these kind of arguments in mind, we can actually talk about the proof techniques that use them. But in the next video, I'll talk about some common fallacies, which are invalid ways of reasoning. And this occurs when one chooses a form that looks like one of these, but it doesn't quite match, and as a result, the conclusion doesn't logically follow. Thanks for watching, and I will see you then.